What's good, YouTube? It's your boy, Zaggy the Codeaholic, back with another video. And today we're going to be solving the problem, adding two numbers. So reading this problem, we have you are given two non-empty linked lists representing two non-negative integers. The digits are stored in a reverse order, and each of these nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume two numbers do not contain any leading zero except the number zero itself. So now we have this example. So as you can see, we have a 2, 4, and a 3, 5, 6, and 4. Those add up, 7, 0, 8. 4 plus 6, you carry 4 plus 4, 8. So you're going to return that. So off the bat, we already know that we're going to need to have a carry type of logic to make sure that when it's like a number like 4 plus 6, we're able to carry it onto the next one. So we know that that's going to be one possible characteristic we need to look forward to, as well as adding these two numbers. So we're going to need a sum as well as a carry. So we're going to start this problem first by making a dummy node. So we're going to say const dummy head is equal to new dot list dot node. So this is what we're going to be returning at the end, and we're going to set the current. It's going to be equal to this dummy head. Then one thing we're going to have to do is we're going to have to establish the carry variable. So let carry, we're going to establish it as 0 for now, just because that's what we're going to start the problem off with, because we don't have any prior information or any prior carry, so it'll be initialized as 0. So now we basically need to separate this into the logic. So now we're thinking we have two linked lists. So we know a linked list, there's only one pointer from one node to the other. You can't go back. So that's pretty important. Another thing is we're going to keep going even when one still exists. So let's say this was 2, 4, 3, 8, and this was still 5, 6, 4. You would still keep going. So it doesn't matter the size. As long as both are not null, you would continue to keep going. So that's one thing. So while L1 exists, or L2, or there's a carry, we're going to have to make sure we keep going. Because there could be a carry of just one, and that'd be the last one, which would create a new digit on the linked list if there's only a carry of one and there's no other numbers, if that makes sense. So we're going to start this problem by getting the sum. So const sum is going to be equal to L1. I'm going to check if there's a value. If not, it's going to be 0. Initialize it as 0. 0, and the same thing for L2. L2, and then plus the carry. Right, so now we need to calculate the carry. So now we need to calculate the carry. So we're going to say the carry is going to be equal to math.floor.sum divided by 10. So basically this will calculate to make sure if there's a carry of 1 or not. Because if you're adding 9 and 9, which would be the two largest, it would be 10 and 9 would be the two largest if there's a carry of 1. That would mean that it'd be 19, and 19 divided by 10, you'll get 1. And the remainder, of course, will be 9, which is what we're going to be carrying over. But the carry will be 1. My bad. The 9 is what's going to stay here, and then 1 will be what's to carry over. So now that we've established the carry, we're going to need to push it to that new linked list that we made. So current.next is going to be equal to a new list node, sum modular 10. Sum modular 10. Basically meaning that, let's say it's 9 and 9. You have the carry of 1, but you're going to push 8. Because 9 plus 9 is 18. You have the 1 and the 8. The 1 is the carry. The 8 is the remainder when you divide it by 10, and that's the part that stays. So then we're going to say, now we're going to move on to, so current is going to be equal to current dot next. And then we're going to keep iterating through the values. So now we're going to say L1 equal to L1 dot next, or null if it's null, and then L2 is equal to L2 dot next, null, and now what we're going to return dummy dot next, which will return all the values. So if we run this and submit it, we will see that it works. So going through this problem again, as y'all can see, this is the logic. So let's say we have the dummy head, L1, L2, 2, 5 plus the carry, so we get 7. Math divided by 4, so 7 divided by 10 is 0. So meaning carry would be equal to 0, meaning there is no carry. And you'd also do it modular by 10, meaning that you would keep the 7 and the 7 would go. And then you'd move on to the next. Then it would be the same thing, 4 and 6 is 0. You have the carry of a 1 that would go over. Then it would keep going and keep going. So yeah. The time complexity here would be O of M of N, basically meaning the max values of L1 and L2. So yeah. If you guys like videos like this and want to see more, please hit that like button, subscribe, and leave a comment on what you guys want to see next. Thanks for watching it. Peace out.